on this problem, we have the data for 25 baseball players. Now, these baseball players' names will change and the stats will change, so your data will be different than mine. So this is just an example. Your data will be different. So on this problem, if you look through it, it wants different correlations. Like the first one wants the correlation between RBI and salary. And if we look up here, here's RBI and here's salary. Well, we can't copy certain columns from this. If I try, you can see I can't just select the RBI column or the salary column. So the way we're going to get around this so that we don't have to type in all this data is I'm going to get the entire table, highlight the entire table, Control C and copy it. Then I'm going to go to our Excel sheet, and I can't paste it into any of these sheets that I have right now, so I'm going to add a new sheet. And the way I'm going to do that is down here on these sheet names, I'm going to right mouse click and choose Insert right here, Insert. And then I'm going to let it choose a new worksheet, put in a new worksheet. Say OK. And now I have a new worksheet. Now I could do this anywhere I wanted to in here to insert a worksheet, but all I'm going to do is put that data in here. So now at the top I'm going to do Control V. So, oops, sorry, let's not do Control V. Let's do it one more time and right mouse click and do Paste Special as text. And there's my salary in right there. Well, all my table is in there. Now I can select the rows that I want. So looking back at the problem, the first part of this problem was, and let me unhighlight this data, down here it wants RBI and salary. So what I'm going to do is get the RBI data. See, here's my RBIs, and I'm going to just get this column, do Control C. And to do correlations, we're going to use this Reg 1 sheet here. And I'm going to do a control, well, I'm actually going to do a paste 1, 2, 3 or a paste special and get that data in there. And I'm going to make sure I don't have any extra data from a leftover problem. So that's my RBIs are pasted in. And now the other problem was the salary. So I'm going to go back to the sheet that I was on, get their salaries, and do the same thing. Control C to copy, and then go to the Reg 1 sheet, and right here I'm going to do a right mouse click and do that paste 1, 2, 3 so that that data is in there. So you can see that data. We can always check it like the first point there to make sure we got everything. 90 and 21.857. We can check that. And we see that that's the two values there, and we can check, make sure we got all of them. Clear down here to the 84. So let's check that. If we scroll down to the bottom, we can see 84, 21.119. So now that you have all your data, as soon as you put that data in there, you have everything you want. So let's see what we're looking for on this problem. This says that we want to get, first it wants to know in order to have a positive. So a positive correlation means we're doing a Righttailed test, and a 5% significance level means we're doing an alpha level of 0.05. The R-test statistic needs to be greater than what value? So let's make sure we have an alpha level of 0.05 and we're looking at the positive correlation. So here we go. So positive correlation, that's a Righttailed test. Make sure your alpha level is whatever it stated. Mine was 5% or 0.05. Now what does the test statistic need to be? Well, in order to have a significant relationship, we need this to be reject. Rejecting the null hypothesis means there's a significant positive relationship. We'll only get a significant positive relationship if the test statistic is larger than the critical value. The critical R is this, 0.3365. So my test statistic, which is my correlation coefficient on this, comparing the R values, needs to be larger than that. So we really don't need what our correlation coefficient is. What this is asking is, what does the correlation coefficient need to be larger than to get a significant relationship? In other words, to reject the null hypothesis. Well, it needs to be larger than this critical R value. So that's 0.3365. So that's the answer to that first one here. So let me go ahead and put that in. So this is 0.3365. And you can see you got to be on the correct tail test, because if you're not, see over here, you can see that you get a different one at 0.05 because it's a two-tailed test. And over here, if you make this 0.05, you get a different value too. You get right here a negative 0.3365. So you got to be looking at the positive tail test. You got to have this 0.05, and what it really wants is the critical R, because this test statistic here, this correlation coefficient, needs to be larger than this value. It is 0.36 is bigger than 0.33, and that's why it rejects the null hypothesis. Here, I'll show you what happens if we change this. If we change this down to, let's say, 0.005, now we get a do not reject. Why? Because my critical R is 0.5, and this correlation coefficient of 0.36 is not bigger than 0.5. See, so you can't reject it at 0.05. We can check 0.01. It's still a do not reject. See, my 0.36 is not bigger than 0.46. See, it's not far enough away to be like 99% sure. But if I change this to 0.05, basically saying I want to be at least 95% sure of my results, I can get that. That's why it says reject here, because this 0.36, your correlation coefficient, is larger than your critical R of 0.33. So that's why we reject. And that was the answer to that problem right there. It needs to be bigger than 0.3365. So now we can get all the other things that it wants. Like if it wants the correlation coefficient, I think I just had that there. That is, let me get it. It is this correlation coefficient, 0.3647. I'll type that in. So that's 0.3647. And then your regression equation, y equals. Well, you can see that in a couple places. See, here's your regression equation right here, and it tells you the slope. See, 0.0956 is the slope, 0.0956 rounded to the nearest like 10,000th. Then here's your y-intercept, 10.135, 10.135. So this is what they want you to type in right here. This 0.0956x. Don't forget the x. I'll tell you what, I might just copy this and paste it in there. Copy and just paste it in. And then there was an x, and then the plus the 10 point something, that y-intercept. Let me see if I can find the y-intercept here. The y-intercept is right here, 10.13. I don't think we can copy it off of this because that does not copy over there. But 10.135 would be good right there for the rest of that equation. 135. And then do we have a significant positive relationship? I think we did, because it said reject. So in other words, you reject the null hypothesis, you're able to show that the correlation coefficient is positive. So there is a positive relationship between these, and this shows you the graph of that right there. So the answer to that bit is yes, there is. Now all I want you to do here on the following parts is use different variables. So we're staying with salary all the way down, but this one is home runs. So all I would do now is go back to the sheet that I was on and get, instead of RBIs, I'll get home runs, get that data, Control C, go to the Reg 1 sheet, and I'm going to put it right here in for my X values. So I'm going to do the paste 1, 2, 3, and now see everything's changed. And I think we're still testing for a positive relationship. You see we don't have one, do not reject, because the correlation coefficient is not as large. It's not as good of a positive correlation here. This isn't bigger than the 0.3365, so you do not reject. Then you would do the same thing, put in the equation and all that sort of stuff. Do the same thing down here on the third one. Then it asks down here, based on analysis, if you had to predict a player's salary, which method would be best? Well, you're looking for the one with the largest correlation coefficient. I haven't done all three, but at this point, this one seems the best. This one was smaller. I haven't done this one. So I'm going to just guess at this point and think that it's the first one with RBI. I'm not sure. And then down here, if the RBI is the correct one, then it says based on your analysis, his predicted salary would be what? So here's a player with an RBI of 104. If that is the best one, I got to plug the 104 in for X on this equation. So I would just use a calculator then and type in, do that arithmetic right here. Or you could go back, assuming you still have that data in there, you could just put that value in for X right here. So that would be like 33.922. So I'll check some of these and see if they're right. Again, I didn't run all of them, but 33 point, I think it was 922. And so that would be what the predicted salary would be. So let's see. And also you have a written example on this, but let's see what we got. If I submit this one, I haven't done the entire problem. You can see that I got the top bit because we finished that. It was the RBIs is the best. Now this one did not come through. Let's check this one. 100. Oh, and the reason that didn't come through is because I already replaced my data in there. So if I would put my data back in and make sure I had the RBI data back then, I would have the correct amount. So I'm going to stop this video here, and we'll wrap it up right there.